We now continue tutorial 4, question 4B. In this example, the thing that is changed is that we will change the voltage source to be a unit step times 10 volts. So it's 10 volts being applied at time 0. And this is again IT. And we also change the resistor to 1 ohm. Inductor remains as 1 Henry and the capacitor is 1/6 farad. Now we are told that y0 equals to 0, y prime 0 equals to 0. The system is relaxed. So this is the relaxed initial condition. And now we are asked to find yt. We can begin with the previous differential equations, and which is this. What we need to do is that when we perform the Laplace transform, we need to use this initial condition as well as the new values of xt, because in the previous equation or the previous question xt was 0, but now it is 10 ut. Let's try. So basically, again, we take these differential equations and perform the Laplace transform using the properties of the differentiations, like second order to become this, the first order to become this, and now we will use the initial conditions to be 0 so that we can remove this, as well as, so now let's cancel these values out because they are all 0, and now we are left with these differential equations representing how the input xs is related to ys. Let's write this equation as well as substituting r equals to 1, l equals to 1, c equals to 1/6, and we have y of s squared plus s plus 6 equals to 6xs. But what is xs? Remember, xt is equals to 10 ut. Therefore, xs is equals to 10 1/s. We work it out. In my solutions, I retain the 1/LC here, 1/LC, and this is xs, which is 10/s for the 10 times unit step. We bring ys, this polynomial, to the other side, and now we are ready to solve for yt. Again, to solve for this step, we have to perform partial fraction expansion, and I'll just show you the steps first. Again, I use residual, and here's the solution. Here's y of s. I express it as the numerator polynomial divided by the denominator polynomial. I use RPK to find these values, and then I substitute the RPKs into the equation over here, and then I can plot the answer. So I'll not remind you how to solve this. It is simply the residual. The first value is 10 for this guy, and the denominator polynomial is 1/6, comma, and the second guy, which is also 1/6, the third guy is 1, and the fourth guy is 0, because look, there is or the 0, or the 1, or the 2, or the 3 of s. So there must be 4 values here. Once you have the residual, we'll get the RPK. So you have R, P, and K, and you can verify them. Each of these elements of R and P are put into here in time domain, which is simply, it is the value of R multiplied by an exponential with the p becoming the coefficients associated, or the power associated with the exponential multiplied by time. So since we have 3 R, R1, R2 and R3, we have 3 of these with the corresponding P1, P2, P3. And this is the final answer for the plotting. From the plot, you can see that the voltage YT starts from time 0, it will overshoot, and finally it will stop at 10 volts. We'll ask you to find initial and final value using the initial final value theorem, and you can check by yourself. Here we use the final value theorem, S times YS, letting S goes to 0. When we solve it, it's 10 volts, similar to our plot. You can see the MATLAB code to generate this MATLAB plot over here. So this is all we have for question 4B. Thank you.